Okay, so this is lesson 11.7, which we're talking about dilations. A dilation is a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. So these will not give you congruent figures, but they will give you similar figures. Identify a dilation. Tell whether the blue figure is a dilation of the red figure. So for example 1a, the lines connecting corresponding vertices meet at a point. Therefore, it's a dilation. Notice what they did. They drew a line that went from the point on the red triangle to the corresponding point on the blue triangle, and they extended that line down. They did that for all 3 points on the triangles, and if those lines meet at a point, then it is a dilation. For example 1b, the figures have the same size and shape, so it is not a dilation. It was just a slide. In a dilation, the original figure and the image are similar. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is the scale factor of the dilation. So the key idea here, dilations in a coordinate plane. To dilate a figure with respect to the origin, multiply the coordinates of each vertex by the scale factor, k. So that's if you're dilating with respect to the origin, meaning the origin would be the point of dilation. When you're multiplying by a scale factor larger than 1, the dilation will be an enlargement, meaning it'll be getting bigger. If you're multiplying by a scale factor that's between 0 and 1, the dilation will be a reduction, or the image will be smaller than the original. In example 2, dilating a figure. Draw the image of triangle ABC after a dilation with a scale factor of 3, and then identify the type of dilation. Well, identifying the type of dilation will be easy because the scale factor is larger than 1, so it is an enlargement. And then it says multiply each x and y coordinate by the scale factor of 3. So the original A was 1, 3. When we multiply the x and the y, each by 3, we get the A prime as 3, 9. 2, 3 becomes 6, 9, and C, 2, 1 becomes C prime, 6, 3. Just multiplying each x and each y coordinate by the scale factor of 3. The image is shown at the right. The dilation is an enlargement because the scale factor is greater than 1. You can check your answer by drawing a line from the origin through each vertex of the original figure, and the vertices of the image should lie on these lines. Notice they drew a line from the origin through A, and it goes all the way to A prime. Those 3 things should line up: A prime, A, and the origin. Same with B prime, B and the origin, and C prime, C and the origin. Then you know you've done it right. In example 3, dilating a figure, draw the image of rectangle WXYZ after a dilation with a scale factor of 0.5. Identify the type of dilation. Of course, this will be a reduction because the scale factor was less than 1. The vertices of XYZ are given. W was -4, -6. We multiply the x and the y by 0.5, which brings W prime to -2, -3. We did the same thing for x to get x prime, y to get y prime, and then z, 4, -6, becomes z prime, 2, -3. Again, all we're doing is multiplying the x and the y of each coordinate by the scale factor. When we draw those, once again, we could connect x and x prime and go right through the origin. Z prime and Z and go right through the origin, W and W prime and go through the origin, and yes, you guessed it, Y prime and Y and go through the origin. Now there's two for you to do on your own. For the first one, you're going to have to go back in the video to see example 2. And for number 4 here, you should be able to just look at this slide right here. For example 4, using more than one transformation, make sure you're following these directions very closely. The vertices of a trapezoid are A, B, C, and D here with their coordinates. It says dilate the trapezoid with respect to the origin using the scale factor of 2. So first you draw on the original trapezoid, and then you dilate it with a scale factor of 2. Since it's in respect to the origin, you're just going to multiply each x and y by 2. Then you draw in that image for A prime, B prime, C prime, and D prime. Then translate it 6 units right and 2 units up. What are the coordinates of the last image? And that'll be A double prime, B double prime, C double prime, and D double prime, and you'll have to say what their coordinates are, which they do here. The image of a translation, reflection, or rotation is congruent to the original figure. The image of a dilation is similar to the original figure because it won't be the same size. In example 5, describing a sequence of transformations. So, the red figure is similar to the blue figure. Describe a sequence of transformations in which the blue figure is the image of the red figure. From the graph, you can see that the blue figure is 1/2 the size of the red figure. So begin with a dilation with respect to the origin using a scale factor of 1/2. After dilating, you will need to flip the figure in the x-axis. So one possible sequence of transformations is a dilation with respect to the origin using a scale factor of 1/2, followed by a reflection in the x-axis. Here are a couple for you to do on your own. In number 5, you're going to have to go back and look at example 4, and in number 6, you can look at example 5 right here.